Hi, Vint. Great. How are you? Vint, it's my big pleasure talking to you 2 years after I interviewed you last time about how the internet works. And by the way, those people who have not seen the interview, have a look. It was a very, very interesting discussion. And I heard there are still people out there not knowing you. So could you briefly describe yourself?
Sure. My name is Vint Cerf. I've been at Google for 13 years now, almost since 2005. But many years ago, my partner Bob Kahn and I designed the internet and led its development. So we're two fathers of the internet. But anyone who's been tracking any of this knows that there are literally hundreds of thousands, maybe even millions of people who have contributed to the internet's evolution, and they continue to do so today.
Wow. Yeah, cool. And so today we have this thing that is called digital transformation, where your technology plays a central role, because without communication, the digital transformation would definitely not have come at this pace. And so when you look at the digital transformation today, so which are the most prominent effects for you that you encounter there?
Well, the first obvious one, of course, is that we have computer-mediated communication, something that used to mean email way back in the 1970s. Today, of course, it means all kinds of modalities. What we're doing right now, using Skype, we could be using Google video conferencing, or we could use FaceTime or many other applications like that. Voice over IP came along in the mid-1990s to transform the telephone system, which today is heavily based on the internet and internet protocols. Perhaps the most important thing, though, is that we're seeing computers intervene in our communication with each other in fairly significant ways. Not only are they the medium through which we communicate with each other, but we're also beginning to communicate directly with computers using more typical human means, natural language processing, natural language understanding, or at least recognition, has become increasingly accurate. And so it's quite common now for people to speak to their computers in order to get them to do things. And we see this with Alexa, with Google Home, and some of the other applications of that type. And along with that is the use of machine learning in order to improve the ability of a computer to respond to inputs that it gets, whether they're oral inputs or, in fact, image inputs or textual inputs. So the computers are playing, as you say, are playing a very key role in intermediating human interaction.
Mm-hmm. So what I found very interesting with the perspective is that the first thing you mentioned is you have humans that want to communicate with humans, and in the middle you have the computer, which is a very positive and nice view. And so when I think about digital transformation, also the transformation of the work environment comes to my attention. And there it's probably not, or depending on the job, of course, not so much about communication between two humans, but also about automating processes. Can you maybe say something into that direction, what it means to you?
Yes, certainly. I mean, we were thinking about e-commerce, for example, as far back as the early 1990s. In fact, I built a shopping mall for the MCI company way back in 1994. But it was a little ahead of its time because not everyone had a smartphone, which didn't come until 2007. So we're seeing several things happening. One of them is the use of computers to organize business, to facilitate electronic commerce, to make products and services more visible to people. And as you can, I'm sure, recognize, companies like Google, Facebook, and others are using computers and algorithms in order to figure out which products and which services should be brought to the attention of the public. So we find computer algorithms intervening in our consumption of products and services, either facilitating their acquisition and use, or even being part of the product or the service, where the computer software is an integral part of the application that you're using. So it's an inescapable fact that software is going to surround us in every possible dimension as the rest of the decade unrolls.
Yeah, and in that dimension, I want to lay the focus on the aspect that the computers are also very good in storing and evaluating data, and so the keywords would be like big data and artificial intelligence for data analytics. So, would you which risks and which chances would you see in these directions?
So, big data, of course, is a popular term these days, and so is artificial intelligence, although I think I would prefer the term machine learning to narrow the scope of the functionality. The two things that strike me are that the machine learning tools are extraordinarily capable of finding signal in a great massive pile of data, looking for correlations, for example. We have to be careful not to mistake a correlation for a cause. That's one very important scientific observation. But there's another thing, and that is that these algorithms are in some cases brittle. They may analyze the data and come to the wrong conclusions. We see this with image processing, for example, where classification fails because a small number of pixels different from the training images cause the system to misrecognize something. And it can be fairly dramatic. I mean, you have pictures of dogs and it recognizes dogs, and then you change a few pixels and it thinks it's a crocodile. And this is a consequence of the way in which the machine learning actually works. So one of our big tasks over the course of the next 10 years anyway is to understand much more deeply how these algorithms are brittle or why they are brittle and how we can make them more resilient and resistant to significant failure. It's a little bit like chaos theory, where you have small changes in input that produce unpredictably large changes in output. One wants a better theory for machine learning tools anyway, so as to avoid some of those consequences.
Mm-hmm. And going into this machine learning direction, and also like with other algorithms, do you think that humans alienate, so they don't understand anymore what happens in the algorithms? And do you see this as a problem? So maybe first for like us computer scientists who are even closer but still don't understand, if you have machine learning, you don't understand what exactly came out, and also for society at large, so people that do not do anything with computers at all.
So the interesting fact, I think, is that with computers, we're able to create systems that we don't understand, whose performance is so complex that we cannot predict it very well. When you think of the billions of devices that are on the internet all interacting with each other, every time one computer sends a message to another computer, it's an experiment because those two computers might never have interacted before. So we really have quite a bit of work to do to be able to understand the way in which these algorithms function, how they might fail. In particular, we might end up training them in such a way as to introduce bias that we don't even recognize. Many people are very worried about software to which we grant autonomy in the sense of making decisions, taking actions. A dramatic case of that is self-driving cars, for example. But imagine algorithms that decide whether or not you can get a loan, or what the interest rate is, or whether or not you are or you aren't insured. These algorithms need to be carefully analyzed, and we need to be on guard that they have not accidentally introduced a bias based on the data that has been used to train them.
Hmm. And when we think about this Uber incident where this woman was tragically overrun, so what I read in the German press was that the sensors were detecting everything properly, but the problem was that the software was not configured correctly, so it was not taking into account all the things that it had. And so this is, to me, this is tragic, because it's like there's a great technology, and then such icon cases as that one, as tragic as it is, where something really bad happens, pushes people away from, puts the trust away. So do you have ideas how we could or what we should do to, so that the average, or not the average, but like people that are not into AI, for instance, or into machine learning, that they can build the trust into this technology and explore it and give it the chance that it should have, because it could bring such great advance.
So this is actually a very, very important point. This whole loss of trust in general, we are losing trust in not just software, but in our institutions as well. This has been eroding over time. The press has become less and less trusted. In the U.S., the Congress is very badly trusted, or not trusted at all. But let me come back to your primary point, which is that when these incidents happen, of course, they're very visible. My understanding of the Uber incident is that the automatic braking system, which is in some sense independent of the artificial intelligence that was part of the Uber system, was disabled. And so the system would have stopped, we think, not because of the AI algorithm, but because the system had hardware in it that was designed to not run into things. And for reasons I don't understand, that was disabled. So, as you say, every time that happens, you get people associate bad things with these kinds of systems, and then assume that they are all not to be trusted. It's going to be hard to build up trust. In the case of the Waymo system that is part of the Alphabet company, I would urge you and your listeners to look at the safety and security protocols that Waymo is using. They've documented these extensively, and you'll find that very stringent testing is done both in the physical world and in the virtual world. And the aspect of the virtual world, which I find the most interesting, is that it's possible for Waymo to present to the software emulated inputs that would normally have come from a sensor. So they can create situations in the virtual world to emulate extreme cases. For example, a ball rolling out in the middle of the street followed by a young child is something that they can test without actually putting a child on the street with a ball and running into it. So I'm very impressed, to be quite frank, despite the fact that I work for a sister company at Google, with the degree of care that Waymo has introduced into its testing regime. That's the sort of thing that we need to document and share with the general public, as you say, so that they can build up confidence in these systems.
And so indeed, Google is probably the company that is doing the most extensive tests, and therefore also doing, like, for the public audience, doing not so much progress over the last, I don't know, the program is running for 8 years or something like that, or for 5 years or 6, 7. But because they do this testing, and then Uber comes and Uber says, like, okay, so I mean, I just hypothesize, but we don't do much testing, we just roll it out, and then let's see what happens. And this is like the typical problem of, like, if you are the first in the market, you can get the market share, but you can also lose the entire trust for the entire field. And so I mean, Google is doing the much more responsible, and I mean, to me, also the only way to go, because it's actually humans and machines, and it's large machines and heavy machines. And would there be like a code of conduct or something needed, saying like, okay, Uber, it's not, or not Uber, company X, whatever, it's not allowed to do this unless we have certain certain levels met?
Yes, well, as you know, there are already definitions for certain levels of automobile operation, level 5 being full autonomy. I believe that makes great sense to have a regulatory regime which requires certain levels of testing and demonstration of capability before you put the cars on the road. We do the same with human beings. We don't let them drive cars until they've demonstrated that they know what the rules of the road are, that they've demonstrated they can control the car, they can park it, they can drive in live traffic. The amount of testing that we do to grant a human a license is de minimis. compared to the amount of testing that we do for self-driving cars. And so one hopes, of course, that the self-driving cars will prove to be safer in their performance than human beings are. But we do need to show that. And statistically, it's going to be important to show that the cars are at least as safe as human drivers and hopefully much more safe.
Uh, and what would you think, like in 10 years, will we have still manual driving?
Uh, yes, I think it will be very hard to eliminate that. However, I can imagine that one might insist that there be no human drivers on certain roads, which are exclusively for use of robot drivers. And the reason for that is that we might have communication between the cars if we can standardize that. So the cars can coordinate with each other about change of lanes and making turns and so on, or even rapid braking, so that it's more than just the sensors that are saying, oh my God, I'm approaching the car ahead of me at a higher rate of speed, when you can be signaling at the speed of light the fact that you're doing something and it might affect other cars behind you or in front of you. So that information exchange might, in fact, increase the safety of the entire system.
Yeah. Okay. Yeah. So yeah, I think so too. And so from what I read, it's like the biggest threat for this autonomous driving, or the biggest problem, is that you have human drivers. Because if you wouldn't have them, the automatic cars could just collaborate, and then even if they're not perfect, by just exchanging information and being like neutral, this will be a much easier game. And so having these specific lanes or even roads for the automatic cars or autonomous cars, or even just for lorries at the beginning or something like that, is probably the
Yeah,
good way.
interestingly, you might not even need lanes in some sense, as long as cars are coordinating properly. Uh, Although I think as long as we have human drivers, we need to have those visual clues about where you're supposed to be.
Yeah, cool. Yeah, and then maybe coming back to what you're currently doing. So what would you say is currently the most important thing you're doing to shape this digital transformation?
First of all, I'm still spending a great deal of my time trying to get more internet infrastructure in place. So I've been encouraging governments and the private sector to work together to make that happen. I've also been very concerned that just getting internet infrastructure in place, like Wi-Fi, for example, or LTE, is not sufficient. That's simply the beginning. We'd like the system to bring useful services to the users, which means local information. It means local languages. It means things that make people's lives measurably better, whether it's improved health care or the ability to drive when otherwise you couldn't. A variety of things that are demonstrably better with, than they would be otherwise. And so this positive feedback is important. So I spend a lot of time on that. I'm spending also a great deal of time right now on the Internet of Things. And the reason for this, of course, is that these things are full of software and the software has bugs. So we have to make sure we can fix the bugs. We have to be sure we can identify them. We need methods for fixing them that avoid, for example, the accidental downloading of malware, which is not the best way to fix a bug. The IoT avalanche, I think, is very important. There are privacy, safety, and security questions. There are questions of autonomy in the sense that you don't want a house full of these devices that doesn't work when the internet connection goes away. So I'm very much focused on that. And the third thing that has my attention is digital preservation, a big concern that digital content may actually evaporate over time, either because you can't find a reader to read the digital medium, or you don't know anymore what the bits mean because the software that knew what the bits meant doesn't run anymore on operating systems of the day. So that occupies a lot of my time. And then just to add one more factoid, I'm also working, as I'm sure you know, on the interplanetary extension of the internet. This work is proceeding. It's taken a long time to get to where we are, over about 20 years, but we now have an operational two-planet system plus the International Space Station. And as new missions to Mars are launched during the 2020s and to the other outer planets, I'm persuaded that we will grow this backbone mission by mission. so that manned and robotic space exploration will get good quality network support.
Wow, so it's not only digital transformation on Earth, but even in the entire
Exactly.
solar system or entire
Yeah.
space. Yeah, that's good.
Today the solar system, tomorrow the galaxy.
Yes, cool. Nice. Then we already come to the end of the interview, and maybe the last question is, for you personally, what does it mean being human in such a world with such lots of algorithms that you daily and even hourly interplay automatically with, voluntarily or involuntarily?
Well, two things. First of all, many of them are quite helpful. I mean, translation, for example, of multiple languages helps me a lot because my language skills are sort of limited. And so Google translations automatically of web pages, for example, are extremely helpful. They're occasionally amusing. You probably know the story about my looking for a weather report in Heidelberg, getting a German weather page, having it translated into English so quickly I didn't even know that it was a translation, and then discovering that the weather report was zero probability of rain, zero probability of fog, and zero probability of ice cream, uh, because ice was mistranslated as ice cream instead of hail.
And you
So
said,
that was a
damn, I
very
wanted ice
interesting.
cream today.
Yeah, yeah, very unhappy about that. So I see a lot of the software tools and artificial intelligence tools as tools, literally, to help augment my own abilities. And I hope that that's how most of them get used, that make us, in some sense, smarter, more capable of doing things that we could not do at scale ourselves. For example, indexing the World Wide Web is not something any human being could do, and yet computers do it very well. I'm frankly looking forward to the convenience and the augmentation of my own abilities. At the same time, I'm very, very conscious of the fact that these tools are not perfect and they can make mistakes, they can be misleading, they can take you to conclusions, for example, that might turn out to be wrong. So we always have to ask ourselves, are we sure that this algorithm is producing good quality results? How can I validate the results using other information, just like you would do in a math problem where you make an estimate of the answer to see whether or not the order of magnitude of the answer matches your expectations. We need to do something like that in the case of these software-based tools.
Okay, very good. So it's a very optimistic point of view, as long as the people implement it right. And so I think,
That's right. So there is a downside to all this, and it's even setting aside the possibility that the software-based tools don't function properly. There are people who deliberately abuse the infrastructure and produce misinformation or generate false, fake news, for example, or inject deliberately harmful information, whether it's malware or simply socially harmful content like bullying, for example, or stalking. And this, of course, is a problem with human beings. They are sometimes badly motivated, and technology can't necessarily stop that. We might try to detect some of it, but we also have to be on guard that when we do see these kinds of things happening, that we have some mechanism for responding. So, at a recent conference at Ditchley House in the UK, one of the conclusions that was reached is that these online systems need to be designed with what we'll call traceability. And this doesn't necessarily mean that everyone has to identify themselves before they're allowed to use the network. But what you want are, under certain circumstances and with the appropriate authority, that you can pierce the veil of anonymity in order to track down a party who is harming someone else through this online environment.
mm. And then this again is like, if it's implemented properly, then this non-repudiation is good because you can track the people down. If it's in the wrong hands, then it might again be a risk, like always. And the I think what is to me always also important is that the digital technologies are also an amplifier. So that
Right.
means it can amplify the good things and it can also amplify the bad things. And so,
That's all true.
yeah,
Yes. We have to deal with scaling in both dimensions. And because human beings are unpredictable and in some cases not trustworthy, we have to build into these systems mechanisms to cope with that.
Cool. Very nice. So Vint, thank you very much for the great interview, and we are looking forward to your talk in September, and hope that also many of the viewers of the interview will come to our event on the 20th and 21st of September 2018 in Heidelberg, and I'm sure you will have even more interesting things, because I always enjoy talking to you, because it's always a source of big inspiration, and it's very nice talking to you. Thank you very much.
Thank you so much, Mark Oliver. Your questions, of course, are always stimulating. I enjoy them. They make me.
Thank you very much.
And I think that's a good thing.
Cool.
Thanks so much.